All right, we're going to wrap up chapter 4 here with a discussion of square roots and cube roots. And this is kind of the last thing we need to talk about when it comes to exponents and powers, because roots are the opposite of powers, because operations in math always have opposites. Addition and subtraction are opposites, multiplication and division are opposites, and likewise powers and roots are opposites. So these operations, or these pairs of operations, always undo each other. So if we learn how to use exponents, we kind of have to learn how to undo exponents, and roots are the way that we do that. So we're only going to talk about two types of roots, the square root and the cube root. First, the square root. The square root of a number is one of its two equal factors. So whenever you take a number and square it, or take it to the second power, you get a number, and then that square root of that number is going to be the number you squared to get it. So the square root of a number is where the square comes from, because a root is the origin or the beginning of something. So to get to the root of the square, you're getting to where it came from. So in other words, since 25 is equal to 5 squared, we say that 5 is the square root of 25, because if I square 5, I get 25. So if I use an exponent to get 25, I use a root to get back to that original number. So if that's the case, what would be the square root of 49? So you need to think, what number squared is going to equal 49? What times itself equals 49? So I'm thinking, what squared equals 49? Well, that would be 7. So 7 is the square root of 49, we would say. So that's what a square root is. And how we write that is we use something called a radical, the radical sign. It's the symbol used to indicate roots in math. And as written, it's the square root. And that little check mark or division looking box is called the radical. And so when you put a number under the radical, you're asking for the square root of it. So we would read this particular example, the square root of 25. Now, when it comes to square roots, there's actually positive and negative square roots. Since the square root of 25 means what number squared gives us 25, so that's the question that the square root is asking. What number times itself gives us 25? There are actually two answers to that question. The first one is obvious. 5 times 5 is 25. So 5 squared is 25. But also negative 5 squared is 25. So there are two ways I can take a number and square it and get 25. One of them is the positive and one of them is the negative. So a take-home message here would be every number has two square roots, the positive and the negative square root. Well, how do you know which one we're asking for? So again, we're going to talk a little bit more about some notation. There are ways to show which root or which roots that we're looking for. Now, if you just see the radical all by itself, like we do right here, that's typically asking for just the positive root. All we want is the positive square root. So when I see the square root of 25, typically, we're going to say that the square root of 25 is 5. It's assumed that we're asking for the positive one. If we want the negative square root, we're just going to put a negative sign in front of it like we did here. So a negative in front of the radical means the negative square root of 25. That would be negative 5. And then what if we want both? Well, we indicate that with this little positive negative symbol here combined, positive and negative combined. That's asking for both roots. So we're going to put that same symbol on our answer, and that positive negative 5 there means both positive 5 and negative 5. It's a short way of saying negative 5 and positive 5. That's what that means when we use that symbol. We're indicating both roots of the number. So it's nice to know our perfect squares, and a perfect square is a number or numbers that have a whole number square root. So if you take 1 and square it, you get 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25, and so on down the line. So these numbers would be important to have memorized, and these go all the way to 15. So this last one here would be 15 squared. This is 14 squared. this is 13 squared, this is 12 squared, and right on down the line. So perfect squares are nice to have memorized because they can give you a judgment of what your square roots are going to be close to, or you'll just know the square root, because there really isn't a direct way to calculate a square root unless you have a calculator or have a lot of time on your hands to do so. So let's find each square root here, and this first one we've already done, the square root of 49. Well, what number times itself is 49? And we're asking for the positive one here. That'd be 7. The square root of 49 is 7. Next one, the negative square root of 16. So we're asking for the negative root, and that would be negative 4. Since negative 4 times negative 4 is 16, that would be the square root of 16. Next one, the positive and negative square root of 100. Well, 10 times itself, or 10 squared, is 100. So we're asking for both roots, so we get positive and negative 10. And then the last one here, the square root of negative 49 is, oh, this can't happen. What number times itself is negative 49? There isn't one. No number times itself is negative 49. If I take 7 times 7, that's 49. If I take negative 7 times negative 7, that's also positive 49. I can't take anything times itself and get negative 49. It would have to be 7 times negative 7. That gives me negative 49. But these two numbers are not the same thing. It's not a number squared. So I cannot get a negative number by squaring something. Anytime you square something, it's going to end up positive. So we say there is no real solution. Sad face. So whenever you see a negative under the radical, that should send up a red flag. You cannot have a square root that is negative. Okay? No negative number has a square root. That is our pro tip. A negative number does not have a square root. So let's estimate these square roots to the nearest integer. Without a calculator, we can't really figure out what the square root is unless we have a lot of time on our hands and could do a lot of guessing and checking. But we're just going to estimate the square root of 60. What is the square root of 60 close to? What is it going to be about? Well, I know that 7 squared is 49, and I know that 8 squared is 64. And 60 is in between 49 and 64, so I know the square root is going to be between 7 and 8. And it's actually going to be closer to 8 since 60 is closer to 64. So I would say that the square root of 60 is approximately 8. And if you have a calculator and actually figure out what the square root of 60 is, it's actually 7.7459, 6, so on and so forth. It's a long decimal number. So we are actually pretty close with that estimate. The next one, what is approximately the negative square root of 23? Well, I know my perfect squares that 23 is in between are 16 and 25, since 4 squared is 16 and 5 squared is 25. And this number is actually closer to 25 than it is to 16. So I'm going to say that this is closer to negative 5, since I was asking for the negative root there. And then the next one, the square root of 14. I know my perfect squares. 3 squared is 9, and 4 squared is 16, and 14 is closer to 16 than it is to 9. So I'm going to say that this is approximately 4. And then the negative square root of 79 is in between. 79 is in between the perfect squares of 64 and 81. So the square root is going to be between 8 and 9. And since we're asking for the negative root, I'm going to say it's closer to negative 9. So estimating square roots by using your perfect squares. What about cube roots? A cube root is similar to a square root, but a cube root of a number is one of its 3 equal factors. So now we're taking something to the 3rd power to get that number. So if x to the 3rd power equals y, then x is the cubed root of y, we say, the cube root of y. So a couple examples there. 2 times 2 times 2, or 2 to the 3rd power, is 8. That means that 2 is a cube root of 8. And since -6 times -6 times -6 is -216, -6 is a cube root of -216. So a couple of things to note here about cube roots. Cube roots act a little bit differently than square roots, so we have to make a distinction here. Here is the symbol that is used for cube roots. It's much like the radical, but there's a little 3 up there. It kind of looks like an exponent, but it's actually a cube root. So we're asking for the third root, not the squared root, is to indicate the cube root of a number. And then 3 points here. Every integer has exactly 1 cube root. This is different than square roots. Square roots, there are 2 square roots of every positive number, but every integer has exactly and only 1 cube root. And the cube root of a positive number will always be positive, because a positive times a positive times a positive is always positive. So if you have a positive number, the cube root is going to be positive. The cube root of 0 is 0, because 0 times 0 times 0 is 0. And the cube root of a negative number can actually happen. That's what makes this different than square roots, because a negative times a negative times a negative is negative. So I can have the cube root of a negative number, but I cannot have the square root of a negative number. So make sure you have that written down somewhere, or keep that in your memory. That's the distinction between square roots and cube roots. So again, perfect cubes is a number that has an integer cube root. So here are some cube or perfect cubes. Notice that there are negatives and positives now, because a negative number can have a cube root. So negative 125, the cube root would be 5, because negative 5 to the third power is negative 125. Negative 4 to the third power is negative 64. Negative 3 to the third power is negative 27. Negative 2 to the third power is negative 8. Negative 1 to the third power is negative 1. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64, and 5 to the third power is 125. So knowing some cube roots would be helpful too if you don't have a calculator. So let's find each cube root here. The cube root of 64, remember, what times itself 3 times, or what to the third power is 64. Now we might be tempted to say 8, because 8 squared is 64, but it's not. We're talking about the cubed root here. So if we just jump back a slide here, we can see right here that 4 to the third power is 64. So I know that the cube root is 4, and it's just positive 4, not positive or negative. And then the next one, the cubed root of negative 1,331. This can happen. I know it's going to be a negative number, though, because a negative number to the third power is still going to be a negative number. And this is actually negative 11, because negative 11 to the third power equals negative 1,331. Now, how would you know that without having all of your cubes memorized? Well, we can actually use the calculator to find roots. Calculating roots and cube roots by hand can be very time-consuming and tedious. So just know that on these calculators, we can do that. So on the left here, the square root button is found just above the x squared button. So you have to press the second button and then press the x squared button, and that will get you the radical, and that will pop up on your screen, and it'll look like that. And you can type whatever you need in the parentheses there to find the square root. Next, we want to find the cube root. So we're going to look for the button that looks like that, which is above the caret or the up arrow. That's the opposite of the exponent button. So when you have to type the cubed root, you have to indicate to the calculator that you want the cubed root. So we have to type a 3 in first, and then find that cube root button. So you're going to see something like that pop up on your screen, and you would find a cubed root that way, because there are other roots besides square roots and cube roots. There's fourth roots, fifth roots, sixth roots. So you have to indicate that you're looking for the cubed root on the calculator. If you can't find it, make sure you talk to me, and I'll help you figure that out.